The second half of this section deals with symmetry. So just like when we studied x and y intercepts, we first learned how to identify them from a graph, and then we changed gears and developed a procedure to find intercepts algebraically. When we work with symmetry now, it will work in a similar fashion. We're first going to study symmetry graphically, and then we will develop a procedure for analyzing symmetry from an algebraic perspective. So in example 3, we are going to learn how to sketch the types of symmetry. So if you just kind of glance through example 3, what you will notice is that I have some pictures, and basically what it is, it's these two pictures. So this first picture kind of looks triangular, and then this other picture on the right is kind of a more of a curve. And if you scroll on, down on this page, you see those two graphs repeated again. And then if you look at the top of page 6, you see the two graphs again. So we see the two different graphs repeated 3 times. And the reason for that is that there's 3 different types of symmetry. So I'm going to make a note up here. Okay, so the types of symmetry that we will encounter are, there's x-axis symmetry, and then there's y-axis symmetry, and then lastly there is origin symmetry. So the reason that these two graphs are repeated 3 times is for each graph we're going to sketch its x-axis symmetry, its y-axis symmetry, and its origin symmetry. Okay, so we're just going through the 3 types of symmetry for both of these graphs. Okay, so let's take a look under sketching the types of symmetry. And if you read the directions in example 3, it says complete each graph so it has the type of symmetry indicated. All right, so in part A, we've got the 2 graphs, and the first thing we are going to sketch is x-axis symmetry. Okay, and you may not know what that is, but there's a little statement there that tells you how you want to think of x-axis symmetry. Okay, it says imagine folding this sheet of paper along the x-axis. Where does the graph end up? Okay, so the key thing, and this is what I always tell students, you have to do some imagining in your head. Okay, imagine if you're doing x-axis symmetry, you're imagining that this were a sheet of paper, and you would physically fold it along, physically fold the graph along the x-axis. Where does the graph end up? Okay, let's start with the graph on the left here. Okay, if you notice, there are 3 key points on the graph. Okay, and I'm actually going to write them down. It's not necessary to write the points down. I'm going to make a chart of where they started and where they end up, and that's not necessary, but I want to do this. There's a reason I'm doing this. Okay, so just hang tight and you'll eventually see why I'm doing this. Okay, all right, so there are 3 key points here. Every point that's in blue is on this graph, but 3 of the points are emphasized. So like if you look at this point right here, this is -8, 3. And then this point right here is -6, 7. And then this last point on the x-axis, that's -4, 0. Okay, so I'm going to say these are the original points. Okay, and now we're going to try to draw in the symmetry. I'm going to put that in, I guess I'll put it in red. I'll put it in a different color. Okay, so again, we want to imagine, okay, if we fold the sheet of paper along the x-axis, where does the entire graph end up? Okay, what you need to do here is move the 3 key points, and then once you move those 3 key points, the entire graph will move as a result. Okay, so let's try it. Okay, so here is the x-axis right here. okay, you want to imagine that you're folding the sheet of paper along the x-axis. So what's going to happen is, if you remember what quadrants are, this is the first quadrant, the second quadrant, third quadrant, and fourth quadrant. Okay, if you folded the sheet of paper, quadrant 1 will come down and lie on quadrant 4, quadrant 2 will come down and lie on quadrant 3. Okay, so we just kind of need to imagine where is each key point going. Okay, so let's start with the point -8, 3. Okay, so fold that sheet of paper. So currently it's 3 units above the x-axis, and so if you fold the sheet of paper, it's going to go 3 units below the x-axis to right here. Okay, it's going to go to this point, and that point has coordinates -8, -3. Okay, so that's where that one particular point ended up. Okay, all right, let's do this for the next point. Okay, so -6, 7. Okay, fold the sheet of paper. Okay, it is 7 units above the x-axis. When you fold the sheet of paper, it is going 7 units below the x-axis. Okay, so it's going to end up at the point -6, -7. All right, and then finally, if we look at that last key point there, okay, the one that's on the x-axis, okay, so at -4, 0. If you fold your sheet of paper, because this point is on the x-axis and you're folding along the x-axis, this point is actually going to stay put. Okay, it's not going to move. Okay, you can also think of it, it's 0 units above the x-axis, so when you fold the sheet of paper, it's going to go 0 units below the x-axis. Okay, so your 3 key points have been translated. This is now where they live. And remember, every point in blue is moving. Okay, even though there's not, a circle right here, that because that point is in blue, it is still a point on the graph. Okay, so the whole graph has to move, but by moving these 3 key points, the entire graph moves. So now what we're going to do is go to each pair of points and connect with a line. Okay, so like these 2 points were connected with a line, so these 2 points are going to be connected with a line. Okay, so it's going to look like this for this particular line segment. Okay, and then these 2 points right here were connected with a line segment, so I need to do the same with these 2 points. Okay, so what I have drawn in red is the graph, the blue graph, flipped about the x-axis. Okay, it's the x-axis symmetry that has been drawn in. Okay, if you fold the sheet of paper along the x-axis, the blue graph will lie directly on top of the red graph. Okay, all right, so let's move on to the graph on the right. Okay, so this has a different shape. Okay, this is more of a curve. Okay, I'm going to do the same thing. I'm going to keep track of the original points and then where those points end up once we draw in the symmetry. So let's see here. The original points here, before we flip the page, the original points here are -8, 6, 0, 5, and then this point right here is 8, -2. Okay, again, every single point in blue is a point on the graph. Okay, even if it doesn't have a circle emphasized on it. Okay, so for example, this point right here is on the graph. It just doesn't have a circle emphasized. Okay, to move this entire graph, we're going to move the 3 key points. Okay, and then the whole graph will move. Okay, all right, again, you want to imagine folding the sheet of paper along the x-axis. Okay, so you would fold the sheet of paper along this yellow line. Where of each of these points going to go? Okay, let's start with the first point, which is -8, 6. Okay, it is currently 6 units above the x-axis. Okay, so if you fold that sheet of paper, it's going to go 6 units below the x-axis. It's going to end up at -8, -6. Okay, that's where it's going to end up. Okay, and then if we look at the point 0, 5, okay, it is 5 units above the x-axis. So if you fold the sheet of paper along the x-axis, this point is getting sent to 0, -5. Okay, and then if we look at this last point, 8, -2, okay, it is 2 units below the x-axis. So if you fold a sheet of paper, this guy is getting sent 2 units above the x-axis to 8, 2. Okay, so those 3 key points have moved, and then you want to connect them with the same basic shape, so this curve shape. Okay, so I'm going to just draw this in. Okay, so this red graph, this red curve, is the x-axis symmetry. Okay, if you fold the sheet of paper along the x-axis, the blue curve is going to lie directly on top of the red graph.